Welcome to this section where we solve questions on Taylor series, which is under power series. Here we talk about estimation close to a certain figure. But if it is a Maclaurin series, it is just about the whole terms. But this one we have known if we have already known the value of a function for a value. But when we increase the value or we reduce the value a bit, what will be the expression to evaluate it? That is what Taylor series is all about. Now let's solve this question using Taylor series. It says expand cos x plus h as a series of power of h and evaluate cos 31 correct to 5 decimal places. Now let's see. Now let's see the general expression for Taylor series. It says when we have function x plus h, the value is going to be fx plus h, the first differential of x with the value of x, plus h squared over 2 factorial, plus second differential and the value for x, and it continues like that. So if we are going to do that of cos x plus h, this is how it's going to be. So cos x plus h, look at the expression, is cos x plus h, first differential x plus h squared over 2 factorial, second differential of x, and continues like that. So we later try to get what fx will be, the first differentiation, second differentiation, up to the fifth. And now it is now slotted into the expression. So cos x plus h is going to be cos x minus h sine x minus h squared over 2 factorial cos x plus h cubed over 3 factorial sine x plus h raised to the power 4 over 4 factorial cos x minus h raised to the power 5 over 5 factorial sine x, and it continues like that. So we have gotten the first part of the question, which is expansion of cos x plus h. We are now asked to find cos 31. And how do we do that? You know, when we are working like this, the angle must be in radians. So this is what it's going to be. So cos 31 will be equal to cos 30 degrees plus 1 degree. Cos 31 degrees is going to give us cos 30 degrees plus 1 degree, and that is cos pi over 6 plus pi over 180 degrees. Pi over 6 is 30 degrees. 1 degree is pi over 180 rad. So from there, we will now be able to slot in pi over 6 for x and pi over 180 for h. Pi over 6 for x and pi over 180 for h. So pi over 6 will be our x now, and pi over 180 will be our h. Now let's get the expression out. So the resulting expression after substitution is equal to cos pi over 6 minus pi over 180 multiplied by sine pi over 6 minus 1 over 2 factorial multiplied by pi over 180 squared times cos pi over 6 plus 1 over 3 factorial multiplied by pi over 180 cube sine pi over 6 plus 1 over 4 factorial multiplied by pi over 180 raised to the power 4 cos pi over 6 minus 1 over 5 factorial pi over 180 raised to the power 5 multiplied by sine pi over 6. And let's see what it gives us. Now take note. Cos pi over 6 is root 3 over 2. Sine pi over 6 is half. And pi over 180 is 0.01745 329252. Or you might not even convert it. Just slot it into the, slot this 3 into the expression given here. So the answer is 0.85716 7300702, approximately 0.85717 to 5 decimal places. So you can see the fun in handling all this mathematics problem. Let's try another one. So the question says, express sine x plus h as a series of powers of h and evaluate sine 44 degrees correct to 5 decimal places. We know we are handling this using Taylor's series. And how do we do that? We just go straight to express sine x plus h as a series. This is how it looks like. So this is how it will be like. Sine x plus h will be equal to fx plus fx. Yeah, fx is the first differential of sine of fx. Fx is sine x from Taylor series. So this is what it will now give expression the terms what fx and the other f of x is. Now from Taylor series, fx is sine x, and when you differentiate fx, it will give us the first differential, which is cos x, and we continue to differentiate them in terms. So the second one will be minus sine x, third is minus cos x, fourth is sine x, and fifth is cos x. Now let's slot it in straight into the expression. So sine x plus h now becomes sine x plus h cos x minus h squared over 2 factorial sine x minus h cubed over 3 factorial cos x plus h raised to the power 4 over 4 factorial sine x plus h raised to the power 5 over 5 factorial cos x, and the term goes on like that. So we have solved the first part. It now asks us to evaluate sine 44 degrees. Normally we know the standard term answer for sine 45. So we are going to express sine 44 as sine 45 minus 1 degree. So this is what it's going to be like. Now, sine 44 degrees is equal to sine 45 minus 1 degree. And that is equal to sine pi over 4 minus pi over 180. You know, when we are handling this kind of thing, everything should be in rads. So that's why we are resolving everything to be in rads. Therefore, sine 44 degrees, when we want to express it in series, now to express sine 44 degrees in series, we are going to have it like this. Now, sine 44 degrees is equal to sine pi over 4 minus pi over 180. And we have said that we take x to be pi over 4 and h to be minus pi over 180. Therefore, the expression is equal to sine pi over 4 plus minus pi over 180 multiplied by cos pi over 4 minus pi over 180 all squared sine pi over 4 times 1 over 2 factorial minus pi over 180 all cube cos pi over 4 multiplied by 1 over 3 factorial plus minus pi over 180 raised to power 4 sine pi over 4 divided by 4 factorial plus minus pi over 180 raised to power 5 cos pi over 4 divided by 5 factorial plus, and it goes on like that. Now let's write it out neatly. So now we are now having the expression as sine pi over 4 minus pi over 180 cos pi over 4 minus pi over 180 squared sine pi over 4 divided by 2 factorial plus pi over 180 cube cos pi over 4 divided by 3 factorial plus pi over 180 raised to power 4 sine pi over 4 divided by 4 factorial minus pi over 180 raised to power 5 cos pi over 4 times 1 over 5 factorial. Now we know some values already. So we know that sine pi over 4 equals to pi over cos pi over 4. Sine pi over 4 equals to cos pi over 4, which is equal to 1 over root 2. And pi over 180 is equal to 0.0174 532 9252. Or you can leave it like this. And when we slotted all these figures into the equation, the answer given is 0.6946 5837 0459, which is approximately 0.69466 to 5 decimal places. So you can see the most important thing in handling power series is ability to differentiate, knowing the fastest way to get your differentiation, and then the use of your calculator to slot in all the figures in the expression. At the end of the day, either you are using computer or you are using calculator, you get your answer. Thank you very much. If you need any help or you have any questions to be answered, any gray area to to bring illumination on, you can send your message through the comment section or the channels in the description. Thank you very much, and please share, comment, like, follow where necessary, and let others who need to come on board, let them know about this channel, please, and assist us in whatever way you think you can. Thank you very much.